Hello everyone. In this video, we are going to solve Physics 2019 Waec past questions. This video does not contain the objectives. This is just the theory part. Alright, so the theory part consists of section 1 and section 2. So in this video is going to cover only section 1. Alright, section 2 is going to be covered in the next video. So let's go ahead to start from number 1. Number 1 states a stone of mass 20 gram is released from a catapult whose rubber is stretched through 5 centimeters. If the force constant of the rubber is 200 Newton per meter, calculate the speed with which the stone leaves the catapult. The first thing we are going to do is to write out the parameters. First, we have mass of 20 gram. Converting it to kilogram, we have 0.02 kilogram. That is dividing this by 1000. The next thing we have is the extension of the rubber. Alright, so the extension is equal to 5 centimeter. In converting it to meter, we have 0.05 meters. That is dividing this by 100. Then the next thing is the force constant K, which is equal to 200 newtons per meter. Now, the stone is released from a catapult. This means that the stone is going to possess kinetic energy. However, the rubber of the catapult is being stretched. It means it undergoes elastic potential energy. This elastic potential energy is equal to the kinetic energy of the stone. I repeat, the elastic potential energy of the rubber is equal to the kinetic energy of the stone. Therefore, we have this, where this is the elastic potential energy of the rubber, and this is the kinetic energy of the stone. Imputing all these parameters, we have this 1/2 multiplied by 200, which is the force constant, multiplied by 0.05 squared, which is the extension, is equal to 1/2 multiplied by 0.02, which is the mass, and v squared is what we are looking for. Alright, this 1/2 can cancel out this 1/2. So we have 200 multiplied by 0.05 squared to give 0.5. And this is equal to 0.02 v squared. V squared is equal to 0.5 divided by 0.02. That is making v squared the subject of the formula. That gives us 25. The square root of 25 is equal to 5 meters per second. Now this is the velocity of the stone, or the speed with which the stone leaves the catapult. Number 2. So we have a diagram over here, and it states the diagram above illustrates a projectile motion. Identify each of the physical quantities labeled P, beta, H, and R. Now, beta is the angle of projection, while P is the initial velocity. H is the maximum height attained, and R is the range, simply the horizontal distance covered from the point of projection to the point with which the stone or whatever object it is lands. So, P is the initial velocity or velocity of projection, beta is angle of projection, H is maximum height reached, and R is the range or horizontal distance covered. Now 2b, write an equation to show the relationship between P, G, and R max, where G is the acceleration due to gravity and R max is maximum range. Let's go back to the diagram so I'll show you something. Here we have range, and this is the horizontal distance covered. Range is maximum when this beta or angle of projection is equal to 45 degrees. The formula for range is u squared sine 2 theta over g. So at 45 degrees, it means that sine 2 theta becomes sine 90, because 2 times 45 gives 90. So we have u squared sine 90 over g. And sine 90 is equal to 1. It means range becomes u squared over g. This range that is u squared over g is called maximum range. Now in this case, the u squared is the initial velocity, but right here our initial velocity is p. So we are going to substitute u squared for p. Then we have p squared over g. So our maximum range is p squared over g. So R max is equal to p squared over g. And this is the relationship between R max, p squared, and g. Alright? P, g, and R max. This is the relationship between them. Number 3. State 3 observable phenomena in which waves behave like a particle. The first one is photoelectric effect. Second one is thermionic emission, and the third one is Compton effect. So we have a last one, which is emission and absorption of light. Now you can choose any of these three as observable phenomena in which waves behave like a particle. Alright, the question says state 3, but there are 4 here, so you can take any 3. Okay, so let's move on to number 4. List 3 magnetic elements that determine the Earth's magnetic field at a point. Right? List 3 magnetic elements that determine the Earth's magnetic field at a point. So the first one, we have angle of dip or inclination. Angle of dip or inclination. This is the angle between the direction of the Earth's resultant magnetic and the horizontal. The second one is angle of declination or variation. Angle of declination or variation. This is the angle between the geographic and the magnetic meridian at a place. The third one is horizontal component of the Earth's magnetic field. Horizontal component of the Earth at a point is the magnetic force acting in the horizontal direction. It is simply the magnetic force acting in a horizontal direction. So these are the 3 magnetic elements that determine the Earth's magnetic field at a point: angle of dip, angle of declination, and horizontal component. Number 5. Explain each of the following terms as used in electronics. This is a question under semiconductors. Alright, semiconductors have properties of conductors and insulators. So I'm not going to go deep into the explanation. So let's quickly explain these terms as used in electronics or semiconductors. The first one is free electrons. These are negative charge carriers. Okay, these are negative charge carriers. And the second one is holes. These are positive charge carriers. All right, so the electrons are negative charge carriers, while the holes are positive charge carriers. Number 6. State the principle of operation of fiber optics. Fiber optics works based on the principle of total internal reflection of light. All right, there are so many applications of total internal reflection of light, and one of them is the fiber optics. Do I need to explain total internal reflection of light? Okay. All right, so let's move ahead. State 2 applications of fiber optics in medicine. State 2 applications of fiber optics in medicine. The first one is light guides. The second one is imaging tools. And the third one is laser for surgery. I repeat, the first one is light guide. The second one is imaging tools, and the third one is laser for surgery. So let's go ahead to explain this one after the other because it seems strange somehow. So when we talk about light guides are used to distribute light from the source to a particular area that requires illumination. So in medicine, whenever a doctor or doctors wants to determine a person's digestive tract, right, to see what's going on there, normally the endoscope is used. All right, endoscope is a non-surgical procedure used to examine a person's digestive tract. And how this is done is that a light is being passed through a person's lung with the aid of a camera, and that camera is going to capture whatever it is in the person's lungs or stomach, which is seen on the screen. All right, so light guide um, is just to distribute light from a source, normally from the source of fiber optics, right, to a particular area that requires illumination. All right. The second one is imaging tools. Imaging tools. This refers to tools such as the X-rays used for scanning. All right. There are other tools, but let's just limit it to X-rays because of time. All right. And we all know what X-ray is used for. Say, for instance, there is a fracture of bone, and they want to determine the extent of that fracture. X-ray scanning is used. All right, for that purpose. Now the last one is laser for surgery. Laser for surgery. Laser surgery is a type of surgery that uses special type of light beams instead of surgical instruments. Alright, so instead of using surgical equipment to carry out surgeries, laser beams are used or is being used to carry out the surgery. And one of the examples of the type of surgery is to remove tumors, right? And another one is to seal lymph vessels. All right, these are few of the surgery that is done with laser surgery or laser beam. And what is laser? Laser is an acronym that stands for light amplification by stimulated emission of radiation. Okay, so let's move on to the last question, which is question 7. Define diffusion. Diffusion is a tendency of molecules to migrate and fill an empty space due to their random thermal motion. And here we are to state two factors that affect the rate of diffusion. The first one is the density of substance, mass of substance, and temperature. So you can list any of these two as the factors that affect the rate of diffusion. Alright guys, this is the first part of the theory, which is this is section B part 1.